Okay, let's look at the 2022 AP Calculus BC exam. This is question number 2. I am Mr. Carboni, and I am reading these questions for the very first time as I am recording this. So you may get to see me pause and think for a minute, especially in the BC questions. The ABs I went through with a lot of confidence, but sometimes a BC question tricks me up. So let's look at number 2 here. So particle moving along the coordinate plane, looks like we have vector motion. We have dx dt and dy dt. They give me an initial condition, the position at time t equals 4. So I'm going to go ahead and make a note that my x position at time 4 is 1, and my y position at time 4 is 5. And then they give me equations for x prime and y prime. So I'm going to go to my calculator. I need to clear out the stuff that is left over from, no, don't save. There, I'm clear that out. And let me define those functions. I'm going to define, I'm going to call it x1 of t to be the square root, and I'm calling it x1 because it's the first derivative of my x function, of my x position, so 1 plus t squared. And then I'm going to define y1, the derivative of my y coordinate, as the natural log of 2 plus t squared. So 1 plus t squared, 2 plus t squared, natural log, all that looks good. So those are defined in my calculator. And let's go on and start solving some problems. So A, find the slope of the line tangent to the path of the particle at time t equals 4. And so that slope is always measured as a change in y over a change in x. How you get that change in y and change in x may change. And if it's a vector-defined motion, a parametrically defined motion, then that will be y prime at 4 over x prime at 4. And I'm going to do that in the calculator in one big step. So I have to be careful with here. So I'm going to do the division. And I need, oh wait, y prime is what's given. Oh, this isn't, I was thinking I was going to use the derivative at a point command. Okay, so I need y1 of 4 over x1 of 4. That's exactly what they gave me. Hit Control Enter to force the decimal, and I'm getting 0.701. 0.701. Okay, that was nice. Find the speed at time 4 and the acceleration vector at time 4. So speed would be the square root of x prime of 4 squared plus y prime of 4 squared. And we will just throw that in the calculator really quick. So back to my calculator. Whoops, not equals. Let's get rid of that. Control square root, and I need x1 of 4 squared plus y1 of 4 squared. I'm going to hit Control Enter to force the decimal, and I'm getting 5.035. And my acceleration vector would be the vector x double prime of 4 and y double prime of 4. And this is where we will use the derivative at a point command. So let me pull up my calculator. Menu, calculus. No, what is that all about? Clear. Menu, calculus, derivative at a point. I'm going to plug 4 into the first derivative of x1 of t. Control Enter. And then I'm going to repeat that same command, except for my saved function y1. And I'm getting 0.970 and 0.444. 0.970 and 0.444. And I like putting a 0 right there before my there's okay, that's it. Find the y coordinate of the particle's position at time 6. They gave me an initial y coordinate, so my y coordinate at time 6 would be, not plus, would be my y coordinate at 4 plus whatever the change is from 4 to 6 of y prime, which is my y1 of t function. So I'm going to go to my calculator. That's going to be 5 plus shift plus, and I'm going, what was it? From 4 to 6. 4 to 6 of my saved function y1 of t dt. Control Enter to force the decimal, and I'm getting 11.5705. 11.5705. 705, which you could round up to 11.571. You could truncate that at 11.570. I'm just going to leave it like that. That's it. And the total distance, this is a nice question. If you know your particle motion, your vector, your parametric formulas, this is about as nice a BC question as you can get. Total distance, antiderivative from 4 to 6. And total distance is the antiderivative of your speed function, which will be x prime of t squared plus y prime of t squared dt. Make sure I'm reading this correctly because there were no curveballs at all in this question, straight up out of the textbook. All right, so go to my calculator, shift plus 426, come back, 426 of the square root of x1 of t squared, get out of that exponent, plus y1 of t squared dt, control enter. 12.136 is the answer I'm getting. Nice question. Nice question. Zip through that one. There's question number 2. Let's move on to 5.